All right, sorry about the few minutes late start. Google Chrome is being playful this morning. So we are going to wrap up Module 9 today. We should be able to wrap up Module 9 today, I hope. Quick reminder, office hours, right? There are like a few resources that are available in this class, and a few, I mean, like 38 plus hours of TA hours every week is kind of decent, okay? So use them. This is like the last 3 weeks, like I told you last time. We are at the end of the first one, 2 more weeks, and then the final exam week. So this is now the time to make the big push, okay? If you are behind, don't worry. No matter how behind you are, we'll help you. We'll try, okay? So just show up during office hours. All right, so one of the things we have left to do is to try to tie things together again. So we do a lot of that because every time we add something new, we just kind of connect it to everything else that we've seen before, okay? So right now what we're going to do is we are going to take strings, we're going to take arrays, and we are going to make arrays of string. And there is nothing like really fantastic about that, except that it's a great illustration of a concept that you are going to encounter over and over and over in the next programming classes, which is a concept of shallow versus deep copy of a data structure, okay? So this is your first encounter with that concept. We are going to look at it with arrays, so a very simple data structure. When you guys make it through COP2512, you start doing linked list with pointers or data structure, and you start to do like more complicated data structure that use links, like for example, trees or graph or something like that, okay? You are going to go back to this kind of stuff, but with a more complicated data structure, of course. So let's take a look at what we have here. So we have an array of 3 int. So integers is a reference variable meant to hold a reference to an array of int object. We create the object here, new int of 3, and then we populate the elements of our array by hand, okay? Nothing transcendental there. Then we use a for each loop. So quick reminder, right? I'm using the easy syntax here because all I want to do is iterate over every element of my array. So I'm not going to use indexes for that. I take a chance to mess it up. So instead, for each value of data type int inside the array referred to by the variable integers, system.out_print value plus a space, and then at the end, system.out_println. We've done that like countless times, okay? So the code itself is not the new stuff. In terms of representation in memory, again, nothing new. I have my variable, my reference variable integers, okay? I have my array object, and I refer to it, and the values 0, 1, 2 are stored inside the array object. Just like any primitive Java data type value is stored. It's always stored inside the variable where it belongs, right? Well, those slots in the array, they are like in variables, so that makes sense that they are stored there. Let's compare this to something a little bit different, slightly different, okay? So I want strings to be a reference variable meant to refer to an object of class array of strings. So an array of something that is not a Java primitive data type. Now it's string, so it's a reference data type. Okay, let's see how that pans out. I'm going to create that array, new string of 3. That array is big enough to contain 3 what? Strings? Hell no. 3 references to string. That's the whole difference, okay? Again, primitive data type, I contain the values. Reference data type, I contain a reference where I find the object, right? And then I initialize the elements of this array. So something new here. Well, literally, no pun intended. Here, I just put the values. But now, since I have an array, and we all say array of strings, what we should say is an array of references to string, okay? But we all have this array now with 3 slots inside. I need to populate them. I need to put references to objects that represent the actual text of the string. So create a new object of class string, make it so that it contains the text 1, put the reference in the array strings at index 0. Okay? So we have one more level of indirection. And then iteration is going to be the same thing. For every value of data type string inside of strings, system.out print value and a space, and then println outside the loop. Inside the memory, strings is still a reference variable. Okay, so it lives on the stack, it contains a reference, I created an object of class array of string here. So this lives on the heap, the memory area called the heap, okay? And it contains 3 slots. So far, so good. It looks exactly like what we did before, okay? And then, well, I have the reference point to that array object. And then I created 1, 2, and 3 object of class string. And I put the references inside each of the slot of the array. So you see the difference, right? It's a little bit more involved here. Those kind of diagram, I refer to them as memory diagram. I just use a very generic term. It's not technical jargon, right? Those kind of memory diagram, they are probably your key for most of you to understanding, as you go forward in data structure and program design, okay? Until now, we have not had a lot of reference. In COP2513, we use references all the time, but this is about as complicated as it gets. Okay, maybe a slightly more complicated next semester, but that's about it. When you hit COP3515, C programming, you're going to learn to use pointers. I cannot stress that out enough. It is essential for you when you deal with pointers to make those kind of diagrams, because you are going to have pretty much references going everywhere, and you are 100% in charge of making sure those references are not messing around. Okay, with Java does half the job. It deallocates for you and stuff like that. With C, no, you're going to be completely in charge. So get used to visualizing things like that in your head, and don't be lazy, right? If you have to write it on paper, take a piece of paper, draw a little diagram, and that will help you tremendously up to and including data structure, okay? So keep that in mind, store it somewhere for now. Right now, what we are going to use this for is to introduce the concept of shallow copy of a data structure as opposed to a deep copy of a data structure. So this we could call it our data structure, right? This is actually a data structure. It's an array of strings. So it's a very simple data structure, but yet when you look at how it looks in memory, there's some levels of indirection. There are like 1, 2, 3, 4 objects plus a variable created. So yeah, it's a nice little playground to introduce ourselves to some concepts that are going to come in handy later on. So what are we going to do with this array? We are going to try to make a copy of it. And you guys know already that if I write, for example, it's not on the slide, but if I write, string array, my strings equals strings, what's going to happen? I'm declaring a new reference variable, and it's going to just point exactly to the same array object here. So I would have 2 reference variables that point to the same array object. It's not really a copy, okay? It's more aliasing. Two pointers to the same object, to the same piece of data. So here I'm going to try to do something that involves actually copying the data that is inside that array. And we're going to realize that there are 2 levels of copy that I can do. Let's take a look at the code we have here. So I declare a variable strings2, which is a reference variable meant to hold the reference to an array of to an object of class array of string. And then I create a new string of 3. So I create a new array pretty much, okay? So here's my variable, my reference variable. I create a new array in memory, and I put the reference of that new array inside the variable strings2. Okay, so I made a copy. The array itself has been copied, but what are arrays initialized with? If those were numerical data types, it would be zeros. If these were Boolean, it would be false. These are references, so they are assigned null, N-U-L-L, which is a keyword in Java, a constant that means 0 for reference. I mean, this reference doesn't refer to any object right now. Okay, we just put null inside of it. So this is done when the array is created for me. Okay, and then what? I'm going to iterate for each value of data type string inside the array referred to by the reference variable strings2. system.out.println value space, blah, 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 system.out.println at the end, okay? Well, what if instead of just iterating over this, because if I try to iterate over this right now, I'm going to try to display null strings. So it's going to display null on the screen. So I'm going to add one little step in between. The step in between is here, system.arrayCopy, blah, blah, blah. So what I'm saying here is I use that trick, that little method that allows me to copy some data from an array to another, right? And I say, I want you to copy from the array referred to by the variable strings. So this is this one. I want you to copy from this one starting at index 0 into the array referred to by array strings 2, that's this one. And I want you to start writing the data starting at index 0 as well. So we're going to start index 0 here, copy, copy, copy. And how many do I want you to copy? Strings dot length. So strings dot length is 3. I want you to copy 1, 2, 3 elements in the array. Here's the thing, folks. If I do this, it looks like I did a copy of my array. Well, it's called array copy. So yeah, you would be entitled, by common sense law to think that the array has been copied. And as a matter of fact, we did a copy of the array, but what we didn't copy were the strings. And this is true for strings. It's true for any object. If I had an array of scanners, an array of employee records, whatever class you have, whatever object you create, you are using references. So making a new array like that of 3 elements and copying everything that is in the old array into the new array is resulting in a kind of weird situation. We call that a shallow copy. That means that, yes, you have a new array object. So those two array objects can live their separate, independent lives. Okay, if you destroy one, the other one is still there, and so on and so forth. Okay, however, they share the same references to the same string object. So string is okay because string is immutable. But what if I had objects here, that are mutable, that can be modified? So that means that I could modify them coming from here. I could modify them coming from here. If you know what you're doing, this is good. This is efficient storage. I mean, we don't duplicate too much stuff. Memory-wise, this is really cool. However, if you don't know what you're doing, or if this is not what you intended, to be able to modify the same object through two different arrays, then you open the door for bugs. Okay? So if I do a bunch of system.out.println here, so if I compare strings index 0 to strings 2 index 0, I get true. I'm comparing with equal. So this is equal to this. And I point here to the slots in the arrays of 3 elements because, yeah, of course, the string object 1 is equivalent to the string object 1, okay? But that's not what I'm comparing, okay? So I do that for the 3 element of the array, I get true. So quick reminder, that's the equal operator being used with references. And we saw that this can go bad real fast. I think this is actually the same slide that I used back then when we first encountered it. I have an example here where I'm comparing the references. Okay, I'm testing if S1 equal S2, S1, S2, S3, S4 are string reference variable. And I compare that to what I get when I do S1 dot equals S2. So I comparing with equal to comparing with the dot equal method. And I told you with objects, always use the dot equal method. However, quick reminder, there are some circumstances where the two of them are going to look like they agree. But that's just a side effect of what we call interned strings in Java, meaning that when you use a literal like this, okay, then Java is going to realize, oh, you want me to create an object of class string with hello in it? I'll do that for you. You want me to do that again? I'm going to be lazy. I'm going to use the other one that I had already. That's why the two references are the same, okay? So if this is a little unclear, come at the end of the session, because this is a review from stuff we already covered. Don't hesitate to ask me questions, okay? But bottom line for now, just to move forward, bottom line is like, yes, that equal stuff is definitely comparing the reference of the object. And now we're going to do the same thing, but we're going to try to figure out, what happens when I do the opposite of a shallow copy, which is called a deep copy of my array. So here's the setup. Strings, A reference variable, same thing. Okay, strings refers to an object, except that I created the object using the block initialization of object syntax, initialization of arrays syntax, sorry. The second one, string2, I create a new array that is exactly the same size as the array referred to by strings. So here's my string2, reference variable. I create the new array. It has a size 3 as well, but the reference inside string2. And then I'm going to do a loop. And this loop here, before I display, okay, this loop here is going to actually copy each element of the array, the first array, into the second by creating a new one. So each string that is in the top array, I'm going to create a new string object to host the copy, and I'm going to copy the value inside of it. So I create a bunch more objects, right? So int I equals 0, I lesser than strings I plus plus, and I'm going to say strings2 index I equals new string, create an object of class string. I pass, when I create the object between the parentheses, I pass actually string index 1, which is a reference to that object. So I say pretty much create a new object, but here's another one, make a copy of this one, right? That's all I'm doing. And here we are, I get this. And I assign the reference to that to my first slot, and I'm done. And then second iteration, third iteration. And what we have here is a deep array copy, where this time everything in my copy is totally independent. Meaning that, yes, I have a new array, totally separate. I have also a new version of every object that was inside the array, and so on and so forth. Real quick, could I use a for each loop here instead of this these indexes? Yeah. Well, the whole point of the for each loop is to get rid of the index, but something is going to go wrong. What is it? The one thing about for each loop is going to be your nemesis. You can do easy stuff. You cannot do complicated stuff. Is that complicated? Well, not so much. But also what I told you is with a for each loop, that variable, for each element in blah, 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 in the array, etc., that variable is kind of like read-only. If you write something to it, if you say element equal new string, blah, 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 you assign to that variable, but you don't change the element inside the array. Okay? I'm going to keep pointing out those things again and again. If you don't remember them, that's okay. That's why I'm pointing them out again, to kind of poke you, refresh your memory. But the only thing you can do wrong at this point is you missed it the first time. I poke you and I say, hey, there's something interesting here. And you're like, yeah, I vaguely remember about it. Let's move on. Now, every time you don't remember stuff like that, go back to the previous lecture, study a little bit more, okay? Ask questions in office hours. All those details accumulate. So the same way that I told you at the beginning of the semester, in a programming class, whatever you learn during week 1, you use it for the rest of the semester. Then week 2, you add more stuff, you use it for the rest of the semester. That like snowball effect, right? It's also true with those little technical details now. M1, M2, M3, we didn't deal too much with technical details. Since M4, we have been doing increasingly with technical details. Treat them just like the basic principle of programming, okay? Don't let any one of them slip under your radar, because that will do a lot of damage later. So it's just a tip for programming class in general. What happens if I try to compare, again, strings index 0, string index 0, 1, and 1? Well, this time it's going to tell me false. So this time I can tell that, even though the first string object up here contains the text 1, and the string object here contains the text 1, so yes, they contain the same text, but because I use equal to compare them, I don't care about what's inside. I care about the references. So I'm really comparing the reference here in the first slot of the first array to the reference here in the first slot of the second array. And it turns out that these are two references to two different objects. So yeah, they are different. So equal is going to tell me false. Okay. So very important that you take the time to go back over those 3 last slides. This one, the previous, and the one before that, and ask as many questions as you need. Okay. If you have question really popping in your mind right now, wave, raise your hand, ask me now. If you need a little bit more time to digest, make sure you digest that thoroughly because this is going to add up really quick. It's dangerous if you skip over it. Okay. Did you have a question? No. Okay. All right. So the last IE that we have this semester, IE9, is going to be, it's not necessarily bigger. It still fits in 2 hours, okay? We have been like scaling it a little bit down, so it should fit in 2 hours without problem. And as usual, don't worry. If you feel that you're short in time, probably you're not the only one. After everybody's done taking an IE, we check, whether, like, for example, nobody was capable to reach more than 50% of the question. If that happens, if there is a significant portion of students that could not go past half of the IE, that means that definitely we messed up something, we made it too big. So then we curve to make up for that, okay? So speed and length is not the problem. But you notice probably that it's worth a lot of points. It's because we are going to try to give you credit for almost every little intermediary step that you can come up with. So it's not a bad thing. Yes, that means that IE9, is worth a lot more points, but that means also that as you are trying to complete things, even if you don't get quite to the end, you should accumulate a decent amount of partial credit. And even more important than the partial credit, you are going to get through the rubric very detailed feedback of exactly all the steps that you took that worked, and then we identify very easily where things stopped working for you. So as always with the IEs, once you take your IE, I want you to go and meet with your grader. Everything you got wrong in the IE, anything that cost you even half a point in the IE, you should actually talk it over with your grader. If they made a mistake, they'll fix it. If they didn't make a mistake, they'll fix you and make sure that you don't make that mistake ever again, i.e. for the final. Okay? Yeah. Are there what? Sorry. Yes. So try to go during office hours, right? Meet with your grader during their official office hours. But I had a student yesterday by Canvas message that told me my problem is that my grader has office hours that don't work with my schedule. That's okay. Bring it up to our attention. You saw probably the post on Piazza. Oran is already trying to reschedule our office hours to meet with that student. So that's how we do it, right? So even if you have like some logistic issues, we'll find a way to make it work. Just say something. All right. So in order to help you prepare further for this IE, here's one exercise, okay, that I recommend. And it's based on stuff that we are partially based on stuff that we have partially used before. So it's going to be a review. It's going to help make sure that that little tokenizer exercise that I did a few lectures ago with you, the one that we use also as a parson puzzle, that puzzle where you had to reorder the order of the code fragments. Well, I'm going to make sure that this is also understood by the vast majority of you. So we are going to use that code. We are going to use a tokenizer, but we are going to re-implement it so you can cut and paste from the previous version. We are going to change it slightly because now we know how to deal with strings. We know how to deal with arrays. So instead of the tokenizer, consuming some input from the user, like a sentence, and displaying on the screen the words one by one, that was what we were doing, right? Now what we're going to do is we're going to have the tokenizer as a method, and that method is going to take as parameter a string which contains a sentence, and you are going to read it from the keyboard, of course, but it could come from anywhere else. Okay, the method is really reusable. So I'm going to take as parameter that string, that sentence that the user typed, and what I'm going to return is an array of actual strings. So that's going to make us practice this, okay? An array of strings, and the first element in that array is going to refer to a string that is a copy of the first word that was in the sentence. So we still, chop the sentence into words, but instead of every time we find a word, instead of displaying that string, we're going to put it in an array, and we're going to return that array, okay? To help us do that, we need what sometimes we call a helper method, like a secondary method that is not part of the official requirement, but that I need to be able to do my job on the main method, the primary method. So what we need here is we need a method that's going to allow us to increase the size of an array. Why? Because when I start with tokenizing like this, okay, you give me a sentence. I don't know how many words I'm going to be able to isolate in the sentence. Again, before to start this exercise, go back and review the tokenizer. Otherwise, it's going to be like much harder, right? So review that tokenizer example that we worked on together, and then try to ease into those extra requirements. So now the thing is, I want to return an array. I don't want to just display every time I find a word or display it on the screen. So I'm going to have to say, I want an array of size something, but I don't know what the size will be. So what I'm going to say is I'm going to say I want an array of string variable named, my tokens. We call them tokens when you isolate, words by word in a sentence like that doing parsing. So I'm going to say this is my array tokens. Do I want to create the array right now? No, because if I create it, I need a size. So instead, what I'm going to say is I'm going to say my tokens is null. So my whole array, it doesn't exist yet. And then the first time that I find a word, I'm going to call this little helper method. And I'm going to say, hey, here's a new word that I found. I want you to add it to this array that I have. And my array at the beginning is null, right? The method is going to be smart enough to check the array that I have, create an array that is one element bigger, copy the content of the old array into it, and add the new token that I passed as parameter at the end, and then return the reference to that. So every time I find a new token, I'm going to say, okay, call that helper method. Here's my current array. Here's my new token, my new strings that I want you to add at the end of an array that has all the strings I found so far. And I'm going to take whatever you return to me, and that's my new array of tokens. Okay? This is not meant for you to just work on it alone. Okay? This is definitely a good candidate for dropping by office hours, working together. It's not graded. Work together as much as you want. Post on Piazza. Okay? Don't necessarily try to go at it alone. If you feel comfortable and confident to go at it alone, by all means, go for it and ask if you need help. Okay? But if you are overwhelmed, don't just step back and say, oh, this is overwhelming. No, 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 no. We will ease you into it. Trust me. Once we get you over that little hump at the beginning, then everything is going to start falling into place. All we need is to be able to pretty much work with you, or you can do it even together if you prefer. All right. So we are going to also use, that organization where we have multiple Java files. So we are going to have my string.java. This is going to be the signature of the tokenized method. So I give you a string with a sentence. You return to me an array of string where each element is one word of that sentence. So you have all the details here. I'll let you take a detailed look. And then we are going to have also in my string.java, we are going to have another method called add token. Again, it takes the current array of tokens that I have. And one of the newest, new kind of new feature that we're going to implement here is that I can pass as parameter null, and then the method will know that I don't even have an array to start off with. So it will create an array of size 1, put the first token to it, and return that. Okay. So it's a neat little programming trick there. But it takes this array of token, it takes the token I want to add, it returns a new array of token with the new token added at the end, and everything else that was in the original array copied into that one as well. Okay? So that's my string.lib. And then I want you to have a second Java file, test my string lib.java. And what we're going to do here is just a main method. And the main method is going to tell the user, give me a sentence, read the entire line, so next line, okay, to read everything that was typed. And then it's going to pass what it read to that method, tokenize, and it's going to get back an array of words, and it's going to display on the screen, these are the words that you typed or something like that, and boom, 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 one after the other as we iterate through the array, okay? Again, we're not fooling around, okay? This is final exam size, scope. For the last 3 weeks, I'm going to pretty much give you some exercise, like practice exercise, non-graded, that are going to really ease you up into the final, okay? But you need to do them. You need to see the end of them, complete them successfully. No matter how much help you need, doesn't matter. As long as you finish them, that's going to help you get ready for the final. Okay. Any question about this? Does that make sense? Yeah. Yes. Definitely. Okay, work on it. You can work on it on your own if you feel confident. If you want to work with other classmates, it's not graded. So there's no, fear of cheating or stuff like that. And of course, office hours, they are a great place, to come and to say, hey, you know what? I don't have an idea on where to start. That's okay. Have a seat, we'll work you into the exercise literally. Don't worry. Okay. All right. You have to take that first step. That's what's generally scary, but okay, to wrap up this module on arrays, we might actually be able to wrap it up. That's awesome. To wrap up this module on arrays, we are going to talk about uh, things that we do very classically on arrays. Okay, like operation that we do on arrays very classically. I already showed you a bunch of them, but those were elementary, iterating for an array, initializing, displaying, stuff like that. Okay, now let's talk about operations that people do a lot on arrays, but that are a little less trivial than that. The first one is I have an array of values. They can be int, they can be double, they can be float, they can be anything, they can be strings. Okay, so my array is kind of a container. I have a bunch of values inside that array. And now the problem we propose to solve is if somebody asks me, look at this value that I have here, is it or is it not in your array? That can be the first level of searching question, right? They want me to search through my array and find out if that value that they gave me is or is not in the array. Or maybe they want even more information. They want me to tell them, if you find this value, give me the index inside the array where it appears, okay? And if you don't find it, just give me a value that doesn't represent an index, like -1. We usually use -1 for that kind of stuff, okay? So all of that these are like just variants that are very close to one another of the problem of searching for a value inside an array. And there are two commonly used approaches to do that. One is called the linear search. You're going to see it's very easy. The concept of it is very easy. The other one is called the binary search. We're going to look into it. That one is a little bit more tricky the first time you encounter it, but you guys are going to review it a lot as you learn recursion. If you don't like it, well, if you know its real name is not binary search, it's dichotomic search, but we stopped calling it that, I guess, because it scared certain way of computing. But bottom line is, it's a very smart way to do it, okay? In terms of algorithm complexity, stuff you are going to learn in data structure, this one, the more data you have, the more time you spend searching. If your array is 1 million elements, you're going to spend, some number of seconds that is proportional to 1 million. If the array is 2 million elements, you're going to spend twice as much time searching. That makes sense, right? The array is twice as big. It takes me twice as long to search for a value. Well, it's not necessarily true when you craft very good algorithm, okay? Like, for example, with this one, the binary search algorithm, if I wanted to express the time it's going to take me to search through that array as a function, a mathematical function of the number of elements I have, okay? When I go from 1 million to 2 million, I would not multiply that time by 2. The time would be actually a logarithm of actually the size of the data, instead of being like directly proportional to the size of the data. That's why we call this linear. The amount of work is proportional linearly to the size of the data that you work with. Binary search, it's the proportion is the relation is logarithmic in nature. Yeah.
Don't you need the binary search to be like a order?
Yes, but it's barely cheating, right? So he's absolutely right. I'm going to show you that in a few slides, right? But to be able to get that boost in performance, because this is a huge boost in performance, okay? And I'm just take my word for it until you take data structure, and then you're going to fully realize what I'm talking about here. But to get such a boost of performance, you're right. We need to pre-process the data a little bit. So we need to take this array that we are going to search and turn it pretty much into a dictionary, like sort it so that every value is ordered. So think about an array of strings, right? suddenly all my strings are in alphabetical order. That's what's going to allow me to jump, in the middle of the dictionary and say, okay, I open the dictionary randomly in the middle. The word I'm looking for, is it before or after this word here on the top of the page? And then I keep doing that, right? That's a binary search. So I can do clever stuff, but I need to sort. So you can tell already that beside searching, one of the other things that we love to do on arrays is sorting them. Okay, so searching and sorting, this is the kind of stuff that we generally cover at the end of an introduction to programming, because these are very classic algorithms in computing. This is also the stuff that's going to be your bread and butter when you take data structure. Okay, you're going to start with that and then explore much more interesting data structures beyond this. So let's start with the linear search, then we'll tackle the binary search, and then we'll talk a little bit about sorting, okay? So I see most of you have your laptop with you. If you have it, but it's closed, like power it up, okay? I'm going to ask you to do a quick little exercise hands-on, okay? And again, the point is not, if you can work through it and you have no problem, that's fine. Just do it, get rid of it, etc. If you have problem, no matter how much problem you have, I will be circulating in the room. Please ask me for help. Let me help you get started, even if you are stuck at the very beginning. So here's the idea of the linear search. I'm going to give you the ID, and then I'm going to throw you in the deep end of the pool and ask you to implement like a version of it. Okay, it doesn't matter if it's like fully finished, polished. It's just a small exercise in class. Okay, so here's the ID. I'm going to ask you to write a method. Let's call it linear search. And that method is going to take an array as parameter. Let's use arrays of int, just something simple, okay? An array of int as parameter. And the second parameter will be a value, an int, okay? So first parameter, an array of int, second parameter, an int. And the deal is, I want you to tell me if that int, is inside the array. And more specifically, I want you to tell me at what index it occurred. So you are going to tell me that by returning a value. That value will also be of data type int because it's an index, okay? So take an array of int, take an int value, return an int value that represents the index where you found that value. Yeah.
Are we assuming there's only one for each integer value is unique?
Very good question. You are assuming that there might be, for example, if I ask you to look for the number 5 in my array, there might be like a 500,000 5, appearing in my array, but I want you to find only the first one. Yeah. You start at the beginning. Very good question. You start at the beginning, and as soon as you find the value 5 in the array, you return, hey, this is the index where I found it. If you reach the end of your array and you didn't find anything, return -1. -1 is not an index, a valid index value. That would let me know you were unable to find that value anywhere in the array. Okay? Let me illustrate how it's going to work real quick. So you have already the description pretty much of the algorithm. Okay, so I'm not asking you to invent the algorithm, but I want you to do a quick implementation problem. Here's the key. So we call it the key generally, the value that we're looking for. Here's my array, which we can call the list or whatever you want to call it, okay, data or whatever. My array contains 64197328, and I'm looking for the value 3. So I'm going to iterate over that array. Is the first element the value 3? No. Is the second element the value 3? Nope. Yes. I return what? I return the index here of that element. 0, 1, 2, 3, 4, 5. In this case, I would return index 5. If you ask me to search for a key that is, for example, I don't know, what number does it appear? 0, okay? I would say, is 0 the first element? No. The second, no. I reach the end of the array, return -1, okay? Not too bad, but let's use that as a warm-up, okay? So try it out. Let's go. And here's some example of me calling your method. So if my list contains 1, 4, 4, 2, 5, -3, 6, 2, and I'm looking for 4, I want you to return 1 because this is index 0, this is 1, this is the first time the 4 appears. If I ask you for -4, it's nowhere to be found, so I want you to return -1. If I ask you for -3, it's here. I want you to return index 0, 1, 2, 3, 4, 5. All right? So get started. I'm going to give you like a minute to get started. Then I'm going to start patrolling. If you need me before that, just raise your hand. And let's get this done during the session. It doesn't matter. Yeah, it doesn't matter. The values themselves can be positive, negative, no problem. I didn't give you a heads up that we need a laptop today, so don't worry about that. Yeah. Do it on paper, or if you want, work with somebody else. Okay, whatever you prefer. Right? Thanks. Anybody completely lost, cannot start? If so, just give me a little hand wave or something like that. Okay. You look like you're doing pretty well so far. So these are going to go in your main. Okay. This is just like when in the main we are going to call the over method to make sure it works. So you'll have a main that does pretty much that, okay? And then you have another method, linear search, that's going to do the hard stuff, right? Cool. Yeah.
Just use like a loop or something to like find everything else, or there's something else we should do.
No, a loop is good. You're going to start with a loop, okay? Let me like scroll back to the previous slide because this one doesn't have much important stuff. You can make up your own examples here. Don't worry about, don't be traumatized by those specific values. But the question was, what about the design? Do I need a loopy statement and stuff like that? Yeah, you need a loop that's going to iterate over every element of the array because you need to look at them, right? All of them. Well, actually, all of them. You need to keep looking at the element of the array until you find the value, like here, or you reach the end of the array. So a while loop will do just fine, for example. And then inside that loop, the comparison, if the key is equal to list at index, whatever index you are on, then I return the index. Otherwise, I keep searching. So it's feasible with a while loop and an if statement inside of it. If you do use more than that, that's okay. That's not a problem at all. Okay, the first versions are always a little bit more involved than the final result.
So let's say, for instance, while number is equals.
So you're going to have to use indexes, okay? And you're going to say, okay, I start with index 0. So that's the first element inside of list. And what I want to do is I want to look at whether index 0, element index 0 is the same as my key. And if it is, return that index, okay? If not, then go again and iterate through the loop, go to the next element and check it out.
So it's just, so it's, so I wouldn't use like a while.
Hmm.
So
Yeah, yeah. I would put, okay, so I would put what is on the, what was on the slide, and I'm going to put it back. Okay, those 3, 4 lines, I would put them in the main method of your program. Okay, I had the same question over there. I would put them in the main method of the program, and then I would write a method. I don't have the signature here, but I would write this inside the main method, and then I would write another method called linear search that's going to take, like an array and a key and return an index. So you separate your job into two methods. Does that make sense? Yeah, public static, and then that method linear search is going to return an int. So public static int linear search. What do you take as parameter between the parentheses? You take an int that we're going to call it key why not, and an array of int that we're going to call list or data or whatever you want.
So the like it's like would the one what are the values be like the number that you put in the cheat?
Yeah, that would be what's in the array, right? In the list. Let me just show you a little bit what I'm talking about, because it's always easier to show visually someone, when you talk about code. When you try to do the verbal only explanation, it's like doing tech support on the phone, for like a coding application. It's not super easy and practical for anybody. So what I'm saying is that inside your main, right, you're going to need, yes, sorry about that. So inside your main, you're going to need an array. So let's say data equal, 1, 2, 3, 4, 5. Okay. And then you're going to call that linear search. So all of that happens inside the main. So for example, you're going to say result 1 equal linear search. And I want to search in that array, and I want to search for the value 3. Okay. And then I would do something like system.out.println, 3 appears at index, and then result 1. Okay. So that's the idea, right? I want to use my method from the main. And then I want to write that method. So to write that method, like you said, public, static, the name of the method is linear search. What does it take as parameters? Okay, first thing, let's start with the parameters. It takes as parameters an array. We are going to call it list to do the same thing as the slides, okay? An array of int called list, and a value, a single value of type int called the key that we're looking for, okay? And what does it return? It returns an index, which is a location where I found that key. So I can start by saying, you know what? I have not found it, return -1. That's my minimal implementation of the linear search. It does nothing. You ask it anything, it says, nope, can't find it, but it's right there, can't find it. That's it. So you could give an array full of the value, it will still return -1. So I'm going to run that real quick. And what I get is, there we go. I ask it to look for the value 3, and it tells me, nope, sorry, the value 3 appears at index -1, which means, I didn't find it. So now the key is, of course, this little method here, linear search, right? So we don't want to do just return 1. We want to do a loop that's going to look at every element in the array. And if we find that element we're looking for, we get out. If we don't, we keep looking until we reach the end of the array. Let me turn this off. Go. Just to give me an idea to pace things out, how many of you are done and it's working? Okay, cool, awesome. So
So if we're using like this scanner, would I even need these?
you could use a scanner. I'm going to say, for now, just call the method like that, with predefined values, so that you don't have to read anything from the user. What you're doing is a job that coding bat does for you in the background. You know what I'm saying? You write a method, but at the same time, you also do the job that coding bat does. You write a main method that just calls it and check that the result is correct. We don't have the code to check the result is correct, but we can display it and check by hand, for example. So after this, I would start working on that linear search method. Okay. So right now, that linear search method says I cannot find anything always. So instead, start with a loop that goes over every element of the array, right? And for each element, ask yourself, is this the same as the key that you gave me? If it is the same, I found it. So now you return, the index where you are at. So you start at index 0. If you find it here, return 0. If you don't, the loop continues. Go to index 1. Is it the key? No. Go to index 2. Is it the key? Yes. Okay. Return it. It returns the value 2. Does that make sense?
So is it like a string? I don't want to like do that part.
So you're just going to think about like the pattern where we iterate over an array of int and we display every int element in that array. Okay, start with that. So we are going to get like a little detour. We're going to write linear search so that it displays the array on the screen. But then once you have that code, we can start like modifying it a little bit, right, to do our search. So a basic loop that goes over every element of the array, display it on the screen. And if you have problems, you guys ask me, okay?
So we're gonna do separate loops for each number. You're just gonna do like if it's
No, just one. Yeah, one is enough. Like you have one array, right? You give me one array. So I'm going to do one loop that says, okay, I'm going to display this, display that, display that, display that, display that.
so what that means you just do if and if.
So for the loop, you need to use while. Yeah.
While keys in.
No, forget about key for now. Okay, let's do something simpler and then we'll grow it naturally into the search. Just display on the screen every element in that array. So while you use those indexes, you start your index at 0, you keep going, and then every time you display on the screen, this is an element at index I. Does that make sense? Okay. I'm going to like get you started here anyway. So little by little, we are going to complete it together. So one of the things that I mentioned here to one of your classmates is if you're stuck, you can start by saying, I want to do a loop. I want to look at every element in my array, right? So how do we do that? So this is where you need to memorize those patterns, of course, but let me like refresh your memory. If I want, so I'm going to use for, but I could use while, I could use do while, it doesn't matter, okay? I just use for because this is the one that we have been using over and over for those kind of scenario. So I want a for loop, okay? And inside that for loop, I want a variable I that's going to be my index, okay? And you guys stop me. If you have question at any point of this process here, stop me. This is what we're doing. We're reviewing, preparing for the final right there already, okay? So I equal 0, and then inside my loop, I want to work with list index I. So I don't know yet how to do the search and stuff like that. Don't freak out. Don't worry. Just do the most basic loop that you can imagine that's going to go over every element of an array. Well, that would be, for example, the loop that does a system.out.println and display that element of the array. So now I have kind of my structure in place. I have my for loop. I know that I is going to be my index. It starts at 0. I use it to access every element in the array. I still need to write the condition of the loop and to increment my index at the end. So again, you can use memory. You can flip through the pages, go back and check a template in the slides or the textbook. But this is going to progressively be something that you internalize. So you're going to remember it without even trying. My pattern for doing that is int I equals 0, I lesser than list dot length, okay, and then I plus plus. So right now, I'm not yet to the point where I'm searching, but at least I have an idea of, I know how to go and take a look at every single element in my array, okay? So if I run this, my loop is going to spin and it's going to display 1, 2, 3, 4, 5, okay? And then when I return from the method, it's going to say the value 3 appears at index -1. That didn't change, okay? But at least, yes, I'm able to go through every element um, of the list. So let's try to find another, and this is part of, when we talked about programming and how to identify like micro features one at a time, this is kind of like what I mean, okay? Like if I'm lost right now, I say, okay, I know how to do this, but now what I want to do is I want to compare every element in that array to the key that you gave me. I want to compare each element in the array to the key you gave me. That's the element in my array, and each iteration is going to be a different one. And I want to compare it to the key that you gave me. So what's going to happen if instead of displaying list index I display list index I equal key? Well, that's a Boolean expression. So it's going to say true or false. Okay? Well, let's try. Let's experiment. Let's see how that works, right? So Control B, Control R. Here's what's happening. I'm going through the array. Okay? The first value of the array is not a 3. So it displays 3 equal whatever the list I value is. I forgot. It's going to say false. There we go. Then it goes to the second value. It's still not 3. It displays false. It goes to the third value. That one is 3. The content of the array was 1, 2, 3, 4, 5, I think, right? So that one is the value 3. So that comparison becomes true. Then I go to the next element. It's false. Next element is false. So that comparison is exactly what allows me to check when I found my element in the list. So I'm not going to use the system.out.println, or at least not like this, okay? I'm going to take this and cut it out of the way. And I'm going to say if list index I equal key, then I'm going to do something like system, we got 1. So I just want to display a message when I find that stuff. Only when I find it, okay? Control B, Control R. So when it runs, it iterates over the array. So sort number 1, sort number 0, actually, it's not the value. Sort number 1 is not the value. Slot number 2, we got 1, found the value, okay? I display a message. Sort number 3, 4, etc. There's nothing to report. If I add in my array multiple times the value 3, so let me go back to the main here and say, for example, I want to do 1, 2, 3, 4, 3, okay? Compile it, run it. We got one. Every time I find it, it says something. So that's neat, but I need more information. I need not only to know that I found it, I need to know where I found it in the array. So I'm going to use system.out.println again, just because I'm tinkering around right now, right? And I'm going to say, instead of we got one, I want to display found at index, and then I want to display, how do I get my index? I. Okay, if list index I equal key, which element of the array is equal to key? The element index I inside of list. So I can just display the value of the index using the variable I. Build it, run it. So now it's telling me I found one at index 2, I found one at index 4. I'm getting one micro step at a time closer to my goal, right? But well, I don't want to do that. I don't want to just display on the screen, right? And as a matter of fact, I don't even care about finding them all. What I was asked, after you ask your question, I kind of refine the problem. What I was asked is, you give me the index of the first one. You return the index of the first one. Well, I know how to find the index. It's here. It's I. Hold on. Once again, there we go. So it's I right here, right? This is my index. So instead of doing all of this garbage here, displaying on the screen, etc., I'm going to say the first time I find the quality that matches, I get out of my method and I return the value of I. There we go. Okay? So now what this means is I'm going to go through every element of the list, but hold on. If I find the value somewhere, the moment I find it, the moment I realize that list index I is the key you wanted me to look for, I'm going to get out of the loop and I'm going to get out even of this whole method and I'm going to return to whoever called me the int that they wanted, which is the index where I found the value. Okay? Build it, run it, and now it tells me 3 appears at index 2. 0, index 0 is 1, index 1 is 2, index 3 is 3. Sorry, 0, 1, 2. So the third one is 3. Sorry, I messed that up. So this time the value that I return is the index where that value occurs. So let's go back to the code here, and it ignores the fact that it appears multiple times. It doesn't care. Okay, this is element index 0, element index 1, element index 2. That's it. And this one, I never reach it. So I could put something different here. It's not going to make a difference. So I have almost everything here. But what if I ask, linear search data and search for the value 999? Save, build, run. It tells me -1. Oh, wait a minute. I didn't code that. So how does it know to return -1? Well, it's because if you look at the code for this method here, and I'm going to remove those superfluous curly braces, okay? If you look at the code for this method together, it has this loop that goes through every element of the array. And if by luck I find the element I'm looking for in my array, I immediately return the index. Okay, so that's what we've seen working already. And then what happens if I go up to the end of my loop, I reach the end of my array, I still haven't found, that element key that you wanted me to look for. Well, I get out of the loop, and my last statement here is return -1. So if I ever reach the end of my array and get out of the loop without doing a return of the index, then the last thing I have to do is to return -1, meaning, you know what? I didn't find it. I'm at the end of my weeds, end of my method. I didn't find it. Here's your -1. So that's it. So we did implement like a linear search like that. The linear search is not too bad as a problem, as a practice exercise, okay? But what's even more important is if you were stuck at any point during that linear search, what's important is to look together at how you go like little step by little step. This is exactly what we learned to do in module 1, 2, and 3. Apply it during your final, apply it during your IEs. Yeah?
Is it possible to do this with a for each loop?
In this case, so it's possible to use a for each loop, but how are you going to know the index value? You're going to have to manage an index by hand. So that means that you would get all the benefit of the for each loop. You don't have to manage an index, but then you are going to have an extra counter variable that you're going to say, okay, every time I go through the loop, I start at 0, and then it's 1 and 2, and you better get it right? Because if you mess that one up, then the value you return is going to be wrong. So that means that you kind of were forced into managing your own counter again. So I would say, just go for the for, with a counter to start off with, because you cannot avoid it one way or the other. Does that make sense? Okay, cool. All right. So let's go back. We should have time to get started on the binary. Let's go back here to our slideshow here. There we go. So you have the code in the slide, okay? So don't worry about it if you didn't finish it right now. It's exactly the same thing, same logic, okay? No problem there. But again, it's not the solution. If I show you that on a slide, it's easy. You look at the slide, you say, yeah, that's not complicated, and you move on, right? But then the question is, can you do it? And when you try to do it, this is when you realize, oh, wait a minute, I'm not sure of this, I'm not sure of that, I don't know how to do this, how to start, etc. So it's really the process that you need to work on, okay? Not just memorizing the solution. So the binary search, let's finish with this one. The binary search is interesting to say the least. So this one, I'm going to leave it for an exercise. So between now and next time we meet, please work on it as well. This is a good practice, but I do expect you to work together, post on Piazza, come to office hours also, okay? I'm going to explain to you the ID of the binary search. First, we are going to always assume that the array that you want me to search through is sorted. So you don't have to worry about that. All that means is when you write your code here in the main, okay, like here, you are going to always make sure that your array is sorted. So you cheat, you give an array that is already sorted to the search algorithm to help it speed up and do a binary search, okay? And then what are we going to do? So we want to return again the index at which the first occurrence of the element appears. So start searching. The first time you find this element, that's it. Give me this index value. I'm okay with it. You don't have to worry about multiple occurrences of the element in the array. And then, if you cannot find it, I want you to return to me the insertion point. That means the index where I should insert it, -1. So you know what? This alone is a problem by itself. So we are going to simplify this for the version I want you to work on between now and next lecture. Instead, return -1. If you don't find it, just return -1. Yeah, you had a question?
Well, I was going to ask.
That's okay.
With that list, if we were given 5, for instance, would we say index 1?
So with that list, if we're given 5, so I would have to trace that. We're going to start. You're going to see how it unfolds. We're going to start at the middle. We're going to say, okay, I need to go in the middle here. I need to go in the middle here. So 0, 1, 2. You would probably return index 2 -1. You're going to see when I run the code, okay? Because I'm going to do a trace of it for you without giving you the code. It's the process of the search make us jump all over the array. So we are going to end up landing here, somewhere around here, right? 4 or 7. And this is where we're going to say this is where it should be inserted after the 4. So if the 2 is at index 0, this is index 1. This is where the value 5 should be inserted. Does that make sense? So? Okay. Okay, that might make more sense when we look at the code, okay? But again, for the first version, don't worry about the insertion point. You know, yes, it's a little bit extra complication. That's generally how we implement that. But for now, we're going to just return -1. But I'm going to show you the logic that allows us even to do that insertion point for some of you. If you're comfortable doing it, please try. All right, so here's the idea. The idea of the binary search, the idea of the whole algorithm is very simple to talk about. It's harder to implement. So we are going to find out what is the index of the element that is right in the middle of the array. So you give me an array of 10 elements, right? I'm going to end up like around index 4 or 5, depending on how you round up, okay? So I find the index of the middle element of the array. I compare the key you want me to look for to that middle element. Since the array is ordered, it's like I open my dictionary roughly in the middle of the dictionary, right? And you gave me a word to look up that starts with an A. So I opened up in the middle of the dictionary randomly, more or less. I'm looking at words that start with the letter J. You want me to look for the letter A as a start letter? So I need to start searching again in the first half of the dictionary. I pretty much decided that I would not even look at the second half of the dictionary because, you know, well, everything that comes after J is certainly not going to be an A, right? So in terms of the algorithm, if my key is lesser strict than the value of the middle element in your array, you're going to say, since my array keeps increasing, forget it. I'm searching again, but only in the first half. And then if it's not lesser than, if it's equal, stop the parentheses. We found it. Return the index value. That's it. If it's greater than, well, then I need to ignore the beginning of the array and search in the second half of the array. Okay? So To illustrate it like we did for the previous diagram, here's an example of a key, 8. And this is my array, 1, 2, 3, 4, 6, 7, 8, 9. So what I do is I compute the index of the middle element. So this is my entire array. This is my middle element. And then I compare middle element to 8. 8 is bigger than 4. So that means that I'm going to ignore all of this because I know 8 cannot possibly be there because the array is sorted. And I'm going to repeat again my process, but starting here and here. So starting here and here, what is the index of the middle element of that sub-array? 7. Depending on how you round up or down, it could be 7 or 8, right? But here I'm rounding down. So between this and this section here, this is a middle element. Is 7 bigger than 8? No. So I repeat again my search. And now I'm searching in this area here. Where is the middle of this area? Again, we're rounding down, okay? So this is the element in the middle of that subarray of 2 elements. Is it lesser than 8? No. Is it bigger than 8? No. Is it equal to 8? Yes. I return the index of that element. I'm done. I keep going like that, okay? Maybe I'm not going to find it. At some point, I keep track of the boundaries. I say, okay, this is a start, this is the end. And then after the first test, I was like, this is a start, this is an end index. And then I said, this is a start and index, this is a start and index. If my start and end index ever cross one another, that's it, I'm done. That means that I went through the entire array, I could not find it, now I'm going to return -1, okay? So I'll leave in the slides, there is another trace like that. I'm going to ask you to try it out. I'll put the solution in the slide, okay? But don't just look at the solution. I know it's tempting, but the amount that you learn from that is infinitesimal compared to actually trying. And if you fail, yes, this is expected. This is a hard one. Come to office hour, Piazza, classmates and stuff like that. This is where you are going to really develop your skills. All right? Thank you, everyone.